All right, welcome. So, every single time you stream a movie or jump on a video call, you're actually counting on this powerful, completely unseen conductor. Today, we're going to peel back the layers of the internet and show you the hidden hardware that makes it all tick.
I mean, really think about that for a second. You click play, right? And almost instantly, a gigantic stream of data zips from some server, maybe thousands of miles away, through miles and miles of cable and lands right on your screen. So, how does that really happen? What's going on behind the curtain?
Well, it's definitely not magic, even though it feels like it. It's more like orchestration, a carefully managed symphony of light and logic. And it's all controlled by that powerful unseen conductor we mentioned.
Okay, so let's get into it. The internet's unseen conductor. What is this thing? Well, the hero of our story today is a piece of hardware called the optical line terminal. You'll usually just hear it called an OLT.
So in OLT, it's basically the central brain of the whole fiber optic network. It's this box that sits in your service provider's local office, and its job is to manage the connection for, an entire neighborhood. The best way to think of it is like an air traffic controller, but instead of planes, it's juggling billions of data packets. It's in charge of every single bit of information flowing in and out of the network to thousands of homes and businesses. It's a huge job. So if this OLT is the brain, right, how do engineers actually tell it what to do? I mean, here's the wild part. This incredibly powerful piece of hardware doesn't have a screen or a mouse or any kind of fancy app. To command this thing, engineers have to speak its native language, and it's a very specific text-only language.
All right, so how do they speak this language? They use what's called a command line interface, or CLI. You can literally think of it as a direct text-only chat window, but you're having a conversation with the very core of the network itself.
And this, right here, this is the front door. This is exactly what a network engineer sees. It's raw, it's just text. They type in a username, a password, and then that command enable to get into what's called privileged mode. And once they see that GPON OLT hash prompt, that means the machine is listening. By the way, GPON just stands for Gigabit Passive Optical Network, which is the type of fiber network we're talking about. At this point, the OLT is ready for its commands, ready to orchestrate the data for a whole community. And here are the basic verbs of that language. They look super simple, right? Words like configure, show, save, reboot. But don't let that fool you. These are incredibly powerful commands. Configure lets an engineer build a whole new part of the network. Show gives them a real-time look at what's happening. And reboot, well, that can restart a modem in someone's house from miles away. Each one of these simple words kicks off a really complex action across the entire physical network.
So how do engineers use this language to actually build and shape the network? That's the really cool part. We're going to start with one of the most important jobs they have, creating what are essentially separate private lanes on the massive internet superhighway.
This idea is called a VLAN, which stands for Virtual Local Area Network, and they are absolutely essential. Think of it like this. A VLAN lets you create dedicated, private lanes on that huge digital highway. This means you can keep traffic from different users or services totally separate and secure. For example, a business can keep its private data on one VLAN while residential internet traffic is on another, and they're both using the exact same physical fiber optic cable. It's all about digital separation. And check this out. This is how it's done. With just a few simple lines of text, an engineer can build a whole new piece of virtual infrastructure. They basically say, okay, VLAN, let's make a new one. Then they pick a physical port on the OLT. Then they tell that port, hey, you're going to be handling traffic from multiple VLANs. And finally, they assign that new VLAN they just created to that port. Boom, done. In just a few seconds, a brand new secure lane has been built on the network. It's pretty amazing. Okay, so building the digital highways is one thing, but the OLT's real job, its true power as a conductor, is managing the flow of all that traffic. It's about making sure everything runs smoothly, especially when things get really, really busy. Because let's be honest, not all data is created equal, right? Your crucial video call for work absolutely has to be smooth in real time. That gets high priority. But that big software update downloading in the background for some app you barely use, yeah, that can wait a few extra milliseconds. This whole process of prioritizing traffic is called quality of service, or QoS, and the OLT is constantly making these lightning-fast decisions for you, behind the scenes. And to keep everything stable, engineers use commands like this one, storm control. You can think of it like a digital floodgate. It's designed to stop what's called a data storm, which is when one device, maybe it's faulty or maybe it's infected with a virus, just starts flooding the network with junk traffic.
Without this command, that one device could slow down the internet for your entire neighborhood. So yeah, it's a pretty crucial defense.
Now, this next one is really clever. It's a technique called IGMP snooping. Okay, so imagine there's a huge live event, like a 4K sports stream that tons of people want to watch. Instead of the OLT just blasting that massive stream of data to every single house on the network, which would be super wasteful, it snoops. It listens in to see who actually requested to watch the game. And then it sends that high bandwidth stream only to those specific people. It is an incredibly efficient way to manage traffic, and it's what lets thousands of us watch the same live event without the whole network grinding to a halt.
But here's where the OLT's power gets really, really impressive. It's not just about managing the local network. The truly mind-blowing part is its ability to remotely command thousands of individual devices. You know, the actual modem sitting in our homes and offices.
Get this, a single OLT can manage the connections for over 1,000 individual user modems. We're talking more than 1,000 different homes or businesses. And it's not just broadcasting a signal out to all of them. No, it can talk to and command each and every one of them individually, from miles away.
This is the true scale of its power. From that central office, an engineer can send a command to your specific modem. The technical term is an ONU, by the way. They can tell it to restart, they can push a software upgrade to it, they can even restore it to factory defaults or reconfigure your Wi-Fi settings if you're having trouble. And all of this happens with just a few typed commands, without anyone ever having to come to your house.
So after all that, after building virtual highways, directing traffic for thousands of people, and commanding all those individual devices, the engineer types one last super simple command, write. And that one word, write, saves the entire incredibly complex symphony of configurations they've just created. It makes it all permanent. The whole performance is now locked in. So the next time your internet just works and your movie streams perfectly, you'll know why. It's not magic, it's this incredibly intricate orchestration, all being performed by an unseen conductor speaking a powerful hidden language. And that kind of leaves you wondering, doesn't it? What other hidden languages and invisible systems are out there, quietly shaping our world every single day?